This is A21 January 10, question 3. Figure 3.1 shows a cross-section of the Earth. Describe and explain how the angular velocity and linear velocity of a person on the surface of the Earth changes as he travels along the Earth's surface from point A to point B on the surface. So from A to B. Now, first bit asks you about angular velocity. So the angular velocity, omega equals 2 pi over t. But t always stays the same because that's just rotation of the Earth on its axis, and that's 24 hours. So therefore omega doesn't change. It also stays the same. And the reason is because it has a constant time period of 24 hours. Linear velocity, however, towards the equator, as he moves towards the equator, the radius of rotation increases. So I'll just show you that. The radius is around the axis, and so there's the radius of the person at A, but by the time they've got to B here, there's the radius and it's much larger. And therefore, since V is equal to R omega, and that's constant, and this is increasing, then V is increasing as well. V increases as well. The radius of the Earth is 6.4 by 10 to the 6 metres. Calculate the centripetal acceleration of an object placed at the equator. Well, the first thing that you need is omega, and omega is 2 pi over t. So that's 2 pi over 24 hours, and it has to be in seconds, so 3,600 seconds. And therefore A is equal to, so the radius of the Earth is 6.4 by 10 to the 6. When you're at the equator, of course, the distance you are from their centre is the same as the radius of the Earth, so it's 6.4 by 10 to the 6, multiplied by 2 pi over 24 by 3,600, and that's squared. And so that gives you an answer of 5.46 by 10 to the 4. So it's 5.5 by 10 to the 4, ms to the minus 2.